Well, as it turned out, I have to start these planetary views all over again. So just a note to myself, delete the other views. Problem was somehow the declination axis got screwed up when I shifted to the east facing view from the west of the previous NGC 6400 to 6500 series of adventitious deep sky studies. What we should be seeing here is Pluto somewhere in the field. And of course, because I couldn't actually determine where Pluto was, I wasn't able to determine that I was looking wildly off in the wrong direction. This is a 1 second ASI image view. It's not stacking, it's real time. 1 second views, you can see it updating about every second. Somewhere in the field is a 14th magnitude star that we should be able to detect at 1 second exposure because 1 second exposures basically represent something along the line of a 12-inch scope, which should be able to envision it, except Pluto is pretty deep south. It looks like it's down in Sagittarius, possibly in Western Capricornus. So what I might do is just boost it up a little bit in terms of the exposure time. What we have here is a 2 second view of the same field. Taking a little longer. These aren't being stacked, of course. The views aren't bad. We're not going to be able to see anything that looks like a planet. Pluto is like, oh, way out there. I mean, if Saturn's 800 million light years out from the Earth, can you imagine where Pluto is? Probably about 2-3 billion miles away. Dozens and dozens of astronomical units, which are each 93 million light years. So Saturn is about 10 astronomical units from the Sun, and I would predict, just modeling in my head, that Pluto must be 50 to 60 or 70. I'll have to look it up to get that straight. Anyway, here is our 2 second view of the stellar region, which could account for the presence of Pluto somewhere in this field. Let's go see if we can turn up a brighter Neptune. Pluto's about 14th magnitude, Neptune about 8. Let's go and see if we can pick it up. Okay, I'm down to 0.5 second exposure time. One of these, I'd say about less than a dozen stellar points on the screen, if the navigation is worked out correctly, is going to be Neptune. And Neptune was discovered as a hypothesis in the 1870s, 1880s by Adams and Leverrier, both independent astronomers, who hypothesized that distortions in the orbit of Uranus suggested there was a massive body outside of its orbit. Both astronomers, Adams, I believe, was British, and Leverrier, of course, was French, did proceed to find the planet at roughly the same time based on those distortions of Uranus's orbit. Uranus itself was discovered by William Herschel, I believe it was William, could have been his son. And that was done based on looking for deep sky studies for the Herschel catalog, and he noticed something moved, but it didn't have a tail. He saw that the rate of motion was pretty slow, so it had to be pretty distant in the solar system, and he was able to discover Uranus at the eyepiece without previously predicting that it would be there. Both Uranus and Neptune aren't what we call gas giants like Saturn and Jupiter, so their influence on the more massive planets would not have made them as easily predictable of their existence. All right, I did notice that Uranus popped up on my hand screen, although I doubt it's probably only just barely above the horizon, although I will point the scope in that direction. Well, as it turned out, two things. First, the scope did not want to navigate to Uranus, so it thought it might have been too low, even though it showed it as being visible. Second, Saturn is not that far from Neptune. They may be sharing the same constellation. So here's a highly overexposed view of Saturn. I think it got at least two of its moons, satellites there, and probably more than that. We should easily be able to see 5. Anyway, I'm going to go ahead and reduce the exposure time. Okay, so here I've dropped the exposure time down to 0.2 seconds. I'll keep dropping it down and we'll see what it looks like. Point 1, it's still overexposed. We're still seeing some of the satellites. Point 1 is about 4.5-inch scope view. Let's have a look at 0.05. Now I'm staying in ASI image for this, and then we'll switch over to planetary imaging in a second. Okay, we're down to 1/50th of a second now. We're still seeing 2 of the satellites, possibly a third right there. On to 0.01. One final satellite is probably Titan, which is the brightest of the satellites. Now we're down to 1,000th of a second, and only Saturn appears in the field. That's as fast as I can go in terms of shutter speed for ASI image. Now we're going to go to the planetary software. This is our initial view using the standard settings that come up. 1,000 milliseconds and gain of 40. I'm going to click on auto for both of them and see if they can correct. Don't seem to be getting any improvement. Okay, I'm going to have to fiddle with the settings. This is a 60x view. I've just switched over to 1 to 100 milliseconds and left, which maxed out the exposure time and left the gain at 130. Remember, Saturn is only about 19 arc seconds in size. It's not particularly impressive. It's also quite low in the sky right now. I'm going to go ahead and wait a couple of hours for it to ascend a bit higher. Right now we're 12 minutes into this video after touring several of the other, at least 2 of the other planets in the system that are available at this time. It's now 10:02. That the 2 minutes matters. Saturn appears to be about maybe 30 degrees ascended to the south and the east. It's lying pretty close to the ecliptic, as you might expect, given the fact it was opposition just about a day before the autumnal equinox. This is a 450x view of the planet. I'll come back out in about another half an hour to an hour and we'll have another look at it. But you know, that ring is looking almost razor sharp. We're seeing the equatorial zone. Notice there's also a matrix on the screen, which means we're exceeding the full resolution of the ZWO imager because we're operating at 150%, which is 450x. Frankly, to get full resolution, complete resolution of Saturn, of a 17 arc second size Saturn, we'd be operating at 240x, because that pushes the resolution of the scope to its maximum, which is 0.8 arc seconds. But the planet is a mere 19 arc seconds in diameter, so we do want to push it up. So here is our 300x view, which actually does reveal more to our eyes. And here is a 450x view, which I think is pretty much optimal for presenting the planet and the ring system at a magnification that human eyes can make out looking at the screen. Let me take a break. We're about 2 minutes into this next snipping tool video. I've already captured 5 minutes of it earlier in the evening. We shall return. Okay, folks, it's still the 22nd of September, but it's now 11:02 in the evening. I'm feeling like turning in. I don't think there's been that much improvement in uh, Saturnine sharpness as it's ascended. It has improved a little bit. I would say there is a sense for short periods of time that we are seeing the shadow of the ring against this hemisphere of the planetary equatorial zone. Got a lot of hopping around, which tells me the atmosphere is quite unstable. We are operating at an extremely high magnification. As I said, I believe it's 450x. Yeah, 150%, 300, yep, 450x. I do believe I have set the focus as tight as it can get under the circumstances. We are seeing the shadow. We are seeing the equatorial zone. The ring itself tends to sharpen briefly. We're not seeing any of the satellites because we've had to reduce the exposure time due to its brilliance. Saturn is quite small, 19 arc seconds. Mars gets larger. I think it gets up to 25 arc seconds, and it's close to its oppositions. Jupiter, however, gets close to 50 arc seconds, and that's the study that really shows the most detail. And of course, a lot of this has to do with where in the sky the planet is visible. So I am going to beg off this evening, and maybe we will capture it again later on as the months progress. It'll get smaller, but it'll be in a better position in the sky earlier in the evening. I could get inspired, however, to come out a few more times over the next month or so. So, tipping a hat to, that is sharpening up pretty good, that shadow at times. Tipping our hat and saluting Saturn, which is now progressing away from opposition to the sun into the earlier evening sky. I'm going to say carpe noctem.